Alright guys, we're looking at the quadratic applications day 2. Okay, so looking at the first question, Jason jumped off a cliff into the ocean, yada yada yada, where t is the time in seconds, h is the height. Okay, so x is the time in seconds, and then y or h is the height in feet. It says how long did it take for Jason to reach his maximum height? So the maximum would be the vertex. And I want to know the x value because it says how long time is the x value in this case. So let's find the x value of my vertex. I can find that with the formula for the axis of symmetry. Axis of symmetry is x equals negative b over 2a. So I'm looking at the opposite of b, so in this case the opposite of 16 over 2 times a, so 2 times negative 16. So I've got negative 16 over negative 32, which reduces to 1/2. Okay, or I could say 0.5 seconds, because 1/2 second doesn't make sense, but 0.5 seconds makes sense. What was the highest point that Jason reached? So now I want the highest point. This would be the y value of my vertex, the maximum value. Alright, so I know that the x value is this. I'm going to plug it in to my quadratic to find the y value. So negative 16 times 0.5 squared plus 16 times 0.5 and then plus 480. Right, I do the math. Okay, and I get 484 feet. And it says, what was Jason's initial height? Okay, so I want to know the initial height, which would be the y-intercept. The y-intercept is always right here, modeled by that. Okay, so the initial height would be 480 feet. So he jumped 4 feet off the ground. Alright, looking at number 2, it says if a toy rocket is launched vertically upward from the ground level, the initial height of 128 feet per second, yada yada yada, how long, again, how long, x value, will it take for the rocket to reach its maximum height? So again, we're looking at the vertex. So again, we're looking for the vertex, the x value of my vertex. So once again, we're going to find the vertex, the axis of symmetry to find the x value of my vertex. So negative b, so the opposite of 128 over 2 times negative 16. Okay, so I've got negative 128 over negative 32. That gives me a positive 4 seconds. What's the maximum height? So we're looking at the y value of my vertex. So we know there is 4 seconds. I'm going to plug that in. So negative 16 times 4 squared plus 128 times 4. The maximum height that the rocket will be is 256 feet. Okay, and it says how long did it take for the rocket to reach the ground? So I'm wondering, what is the second root? Okay, the second root. All right, so I can factor this out. Okay, we're looking for the GCF. For a GCF, this is going to be negative 16. We're going to factor out negative 16. This is going to become t squared minus 8. Right, I'm taking 16 out of here, taking 16 out of here. Becomes t squared. So, sorry. Yes, negative 16 t would be my GCF. So we get a t, and then we get plus. Okay, we factor out a negative 8 out of this, so it's minus 8. Alright, so now this is equal to 0, so negative 16t squared equals 0. Or sorry, negative 16t equals 0. Holy cow. Okay, so t equals 0. That's the first root. I want the second root, so how long did it take to reach the ground? So we're going to set this equal to 0. T minus 8 equals 0. Add 8, so 8 seconds. Alright, number 3, it says you're trying to dunk a basketball. You need to jump 2.5 feet in the air, yada yada yada. What's the maximum height your feet will be above the ground? Okay, so I want to know what is the maximum height that your feet will be above the ground. So we know the y value of my vertex, right? So let's find the x value of my vertex. X equals negative b over 2a. So we've got opposite of 12 over 2 times negative 16. So that's going to give me 0.375 seconds. Now we want the y value of my vertex, so we're going to take that and plug it in. So negative 16 times 0.375 squared plus 12 times 0.375. Okay, and we get 2.25 feet. Alright, so it says you need to jump 2.5 feet in the air to dunk a basketball. Did we jump 2.5 feet in the air? No, we did not. So no, we cannot jump high enough E-N-O-U-G-H enough to dunk. So no, white boys can't jump, right? Alright, looking at number 4, it says the ball is still in the air, the path of the ball is represented yada 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 over the equation, from 0 to 8 seconds. So from 0, 1, 2, 3, 4, 5, 6, 7, 8. Alright, so the height is in meters. Here is my function right there. It says what's the maximum height of the ball? A, so I want to know the y value of my vertex. Alright, so again, x equals negative b over 2a. So we've got the opposite of 8 over 2 times negative 1. So I've got negative 8 over negative 2, which gives me a positive 4. So I know the x value of my vertex is at 4. We're going to plug that back in. So I've got negative 4 squared plus 8 times 4. So I've got 4 squared to 16, so negative of that, negative 16 plus 32. That's going to give me a positive 16. So my vertex is at 4, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's my vertex. Okay. So my graph, okay, looks something like this. Okay. Now, we want to find out how long is the ball above 7 meters. So how long is it above 7 meters? Okay, so 1, 2, 3, 4, 5, 6, 7. Here's your line right there you're looking at. So how long is it above 7 meters? So it's above 7 meters at 1 second, and it's below 7 meters at 7 seconds. So the distance between those two, okay, the time passing between those two would be 6 seconds total. 6 seconds total. Alright, it says list all the transformations. So it says rewrite the equation in vertex form. Well, here's my vertex. Right, so we've got y equals a x minus h squared plus k. We know that, bam, there is the vertex. Okay, so I've got x minus 4 plus 16. Last thing we need to do is make sure that a is 1. Right, so what we're going to do is we're going to pick another point on the graph. In this case, let's just pick 0, 0. It's easy. So I'm going to plug in 0, 0 minus 4 squared plus 16. So we're solving for a. We're trying to figure out if there's a vertical stretch or compression. I chose 0, 0 because that's one of my roots. Alright, so 0 goes in for y, 0 goes in for x. I've still got my vertex in. Alright, so I've got 0 equals a times negative 4 squared plus 16. Right, 0 minus 4 is negative 4. When I square negative 4, I get positive 16. So 16a plus 16 equals 0. Now I need to subtract 16 on both sides. Alright, so I get negative 16 equals 16a. So I divide by 16 on both sides, and I get a equals negative 1. So my vertex form, now I have y equals a, but I know a is negative 1. So negative x minus 4 squared plus 16. Alright, looking at number 7, it says graph the equation to show the path of the donut hole, show at least 3 points. Alright, so here's my quadratic. Okay, I know that I'm going to find my axis of symmetry by negative b over 2a. So opposite of 4, negative 4 over 2 times negative 1. A is negative 1. So I've got negative 4 over negative 2, which is a positive 2. Now I need to find the y value of my vertex, so let's plug it back in. I've got negative 2 squared plus 4 times 2 minus 2. This is blurry. Better. Alright. Alright, so 2 squared is 4, so negative of that, it's going to be negative 4. This is going to be positive 8. 4 times 2 is positive 8, and negative 2. So negative 6 here. 8 minus 6 is a positive 2. So the vertex is at 2, 2. So we go over 2, up 2. Bam, there it is. We know the axis of symmetry also goes through the vertex. So there that is. Alright, so now I've got a point at 2, 2. Some other points on the graph. If I was to make a table, let's choose 1. So we plug that in. We've got negative 1 squared plus 4 times 1 minus 2. So I've got 1 squared is 1. Negative of that is negative 1. This is positive 4 minus 2. That's going to give me a positive 1. So you got a point at 1, 1. If I had a point at 1, 1, that's 1 unit away from the axis of symmetry. So 1 unit away on the other side would be at 3, 1. So we have another point at 3, 1. So there is your parabola right there. All right, so it says at what time does the donut reach its maximum height? So I want to know, going back to my graph, at what time t does my donut reach its maximum height? There's my maximum. There's the vertex. So at what time? 2 seconds. It says what is the maximum height of the donut? Now I need the y value, right? Time was x. Now I'm looking at the y value. Well, how high was it? 2. And we're looking at feet, right? So 2 feet. It says rewrite the equation in vertex form. Okay, and my vertex is at 2, 2. My vertex is at 2, 2. All right, so again, we've got y equals a x minus h squared plus k. We're going to plug in 2. We're going to plug in 2. So y equals a x minus 2 squared plus 2. All right, now we have more points on the graph. Okay, we graphed them. I've got another point at 1, 1, so I can use that to figure out my a value. So this is going to go in for x, this is going to go in for y, and I'm trying to find a. So I've got 1 equals a, 1 minus 2 squared plus 2. 1 minus 2 is a negative 1. Now I can square a negative 1. 1 is going to give me positive 1, so I've got 1a. I'm going to subtract 2 to get a by itself, so I've got negative 1 equals 1a, so a equals negative 1. So to rewrite it in vertex form then, I've got y equals negative x minus 2 squared plus 2. Again, y equals a, we know a is negative 1, x minus the h, which is the x value of vertex, squared plus the y value of vertex.